Organic chemistry. This is our last of 2 lectures of the year, for reals. I know. We're going to start reviewing pretty soon here. Organic nomenclature we've decided to cover because it's going to give you a familiarity with these types of molecules, so when you see them, it doesn't freak you out unnecessarily. We're exposing them to you. We're not testing you over it. That's why we're not giving you a test on this unit, but we are giving you a big group quiz, which is going to be, in a few days, depending upon what year you're watching this video. You will probably have the weekend to study for it. So it is a non-droppable, double-weighted quiz. Okay, it's still a group quiz though, so you still have safety and some numbers, but we want you to really, really learn this stuff, and it's just going to really help you. Yeah. No, you guys will have to figure out how to take it. You have to, people who aren't, there's a lot of robotics people that won't be ready to take it, and there's some other people, and you're going to have to show up and either be in a group or come in and take it by yourself. So I suggest you get here if you can. So we're only looking at nomenclature. So those of you who are taking organic, I don't want you to think that this is what organic is. This is just like nomenclature in chemistry is. It's just like nomenclature in organic. There's a whole world beyond the nomenclature. This is just learning the introductory language. So hydrocarbons are compounds consisting of carbon and hydrogen. And I'm going to let you read all this on your own. But the basics is we know that carbon makes how many bonds? Not rhetorical. 4. And what would the hybridization be with 4 bonds? sp3. So all the carbons we're dealing with will make 4 bonds. They won't always be sp3 though, because we make double and triple bonds, which changes the hybridization. So some terms you need to know. Saturated. Saturated, unsaturated refers to having as many hydrogens as possible. If you're totally filled up with hydrogens, you're considered to be saturated. If you're not, you're considered unsaturated. That's where unsaturated and saturated fats come from. It's literally talking about whether or not the bonds, how many double bonds are in it. If there's a bunch of double bonds, it's considered, or triple, they're considered unsaturated fats. Today, we're going to be looking at the basic nomenclature of alkanes, cycloalkanes, alkenes, or alkynes. So the cyclos are easy. They're just connecting things in a circle. But for alkanes, what we need to understand is that it's going to be a chain of carbons that are all singly bonded. The prefixes are here. You know these prefixes from covalent nomenclature. They're the same prefixes. You have to know 1 through 10 by heart. So let's go through our mono, meth, S, prop, but, pent, hex, hept, oct, and non, and dec. Okay? You have to know those. And all you do is you count the number of carbons in the longest chain of the compound you're looking at. Use that prefix in conjunction with whatever suffix. If it's all single bonds, you say ane, methane, propane, butane, whatever. If there happens to be a double or triple bond present, you say ene or ine, ene or yne. You don't have to memorize this general formula because you can kind of, it'll help you, because if you see something like C10H22, knowing that this exists, this will help you know that that's an alkane, not an alkene. And it's really easy to think about. If you think about it in your head, think about a chain of 10 carbons. If you have 10 hydrogens above, 10 hydrogens below, and 1 on each side, that's where the +2 comes from. Okay? If I have an alkene, I make a double bond, 2 of the hydrogens go away. So what would be the general formula for an alkene? CnH2n. We would lose the +2. Okay? If I had an alkyne, what would the formula be? I make a triple bond, so I lose 2 more. Yeah, 2n minus 2. Yeah, but you didn't. All right, so these are going to be named the exact same way. There's just a subtle thing that you need to understand, and that's the need for a number describing where the double or triple bond is located. So I'm going to introduce just kind of, don't freak out when you see that. You might be thinking, oh my God, what the heck is that? That's just a squiggly line. Well, you need to understand in line structures, and that's how we're going to use it. We're not going to be writing C's and H's. You guys are beyond that at this point. You can handle this. There is a carbon at each intersection and a carbon on the ends, okay? We assume full saturation of hydrogen. So since this carbon is only bonded to another carbon, how many hydrogens would it have? 3. So this is an understood CH3. Some programs, like you'll see when we do our practice problems, put the terminal carbons on for you. You don't need them, but if they're there, don't freak out. It's still a C, and it's still at 3 H's attached. So all of these would be CH whats? CH2s. So anytime there's an intersection, you assume there is a carbon fully saturated. So since this then is 1, 2, 3, 4, 5 in a single chain with no double bonds, what is this called? Pentane, right? But if I do this, 1, 2, 3, 4, 5, and I put a bond there, what would that be called? It's apentene, but that's not the full name, because I could have this or that. 1, 2, 3, 4. Oh, that's a bad example. I could have that or this. There's no double bond there. And those are two different compounds. They're both pentenes, but what's different about them? Location of the double bond. So you have to number the chain where you have the double bond after the lowest number carbon. So this would be 1, 2. This would be 1 pentene. And this would be 2 pentene. Okay, so that's all there is to the double and triple bonds. You have to number them to get those on the lowest carbon. In a few minutes, we're going to talk about substituent groups that you chunk on. The double bond, anything that changes the base name takes precedence in terms of numbering. So you always number to get the double or triple bond in the longest chain first. So I think it's just best now for us to just start naming. With the cyclos, the cycloalkane is going to have 2 less carbons than the chain. Why? Yeah, when you take the ends and attach them, you lose a hydrogen on each carbon. So if I have C5H10, I don't know if it's an alkene or a cycloalkane. It could be either. But knowing that is half the battle. It could be either one of those things, and then you'll get hints otherwise. Okay? Now, these things hanging off are called substituent groups. And you can read these rules later. I think you should read them after I go through examples. But what about these substituent groups? Let me just give you a little. So say we have a butane, and we have a group coming off. These substituent groups, so once you identify your longest chain, if you want to, you can circle your groups just to isolate them. The substituent groups end in YL, and they have the same prefixes that we just talked about. So what is the 1 carbon prefix? Meth. So this is called a methyl group. That's a methyl group. And we have to indicate with numbering where the methyl is. The methyl, if we number this way, could be on carbon 2. If we number this way, it's on carbon 3. Which one do you think is right? Carbon 2. So that's 2-methylbutane. Okay? So if you have a 2-carbon group coming off, that's an ethyl, 3 carbon groups of propyl, and so on. Students want to call that ethyl. No, it's not. This is a methyl, and this is a methyl. Okay? So if you have 2 of the same group, you have to use the prefix di or tri if there's 3 of the same group. So here we have on carbon 2, I'm just going to write the name and then we'll talk about it. This is called 2,2-dimethylbutane. So because we have 2 of the identical substituent group, we're not going to say methyl-methyl. That sounds weird. So we say dimethyl. If you have di, you need 2 numbers Because I could also have this. What's the difference? What would that be? No. Why are we saying 1? What's your longest chain? How many? 4. 1, 2, 3, 4. So that's carbon 2, and that's carbon 3. So what would this be called using this name as a format? 2,3-dimethylbutane. Okay, you always identify your longest chain first. My point here is if you have substituent groups that are identical, you use a prefix and then a number for, if it's a tri, you use 3 numbers. Yeah? Because that's where the double bond was located. Why isn't it 2, 2? It is 2. Because we have to name it. Once you number your carbons, you stick with that name. How would somebody, like, you got to reverse it. If you called it 2, 2, how would a person know that you meant this and not that? Okay? Once you start numbering your chain, you got to continue that direction, for all the naming of everything. Can't change direction on it. All right, so let's just jump in and do some of these examples. I'm going to be hopping around. This first one's a little more complex. I want to do an easier one first. Let's do this one right here. So first thing you want to do, number your longest chain. 1, 2, 3, 4, 5, 6. That's the longest chain. What is a chain of 6? Are there any double bonds there? No. What's this base name then? Hexane. What do we have hanging off the hexane? A methyl. What carbon is that methyl on? 3 or 4? 3, because we're going to count from the side to give it to 3. So this is called 3-methylhexane. The correct format, there's a hyphen between numbers and words, and then the words run together. So it's methylhexane. It's not methyl space hexane. It's methylhexane. 3-methylhexane. Got it? All right, let's do this one right here. Find the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. So 5 is going to be the longest. I could do either up or to the right there. It doesn't matter. All right, so what's my base name? Pentane. I have a methyl and a methyl. 2, 3. 2, 3 what? Dimethylpentane. 2, 3 dimethylpentane. All right, let's look at this one right here. I like this one because this is going to throw you another curveball. You got to try the count different directions, different paths, because you want the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This is 7 as well, so I'm just going to go across this way. Going across the page isn't always the longest group, so you really have to watch that. So now I have, what's that group called I just circled? Methyl, the group I just circled. And then this one, ethyl. So what numbers are these things on? Which direction am I going to start numbering? 2, 4. Now, here's the kicker. You do not put them numerically in order. You put them alphabetically in order. Of course. Of course. So this is an ethyl, we said, and this is a methyl. What comes first in the alphabet? Ethyl. So it's 4 ethyl, 2 methyl what? I already forgot how many things we had. Is it 7? Heptane. All right? We number them so that the lowest number is hit first in the chain. So that's why it's a 2, 4 instead of a 3, 5 or 3, 6, whatever. 1, 2, 3, 4, 4, 6. That's why we number that direction. Then you place them in alphabetical order. This is a poor example for me to give you because it looks like there's 2 different ways to get the longest chain, and there are. We can get the longest chain by just, and I'm not going to write it because I don't want to do it this way, but you see if you go down 1, 2, 3, 4, 5, 6, you have 6, right? That's one big ugly substituent group. Organic chem kids know how to name that, but I'm not going to. We're going to do the IUPAC rules technically say you want to pick the longest chain where you have the most substituent groups, the simplest substituent groups. So if I were to number 1, 2, 3, 4, 5, 6, do you see how doing this way I have now 2 substituent groups? That's what you're supposed to do. So that and that. So it looks to me it's pretty darn close to the last example. What would we call this? It's 6, so it's a hexane. 3-ethyl 2-methyl hexane, correct. Okay. Yes, if you went this way, it would, but see, it's still 2-methyl 3. The name wouldn't change. Yeah, his question was, could we have done this? Doon, 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 doon. Sure, totally. That still would have been a 2-methyl. All right. Okay, now I'm going to kind of be quiet a little bit. 1, 2, 3, 4, 5, 6, 7. Look at what's hanging off of it. What's that called? The whole thing. Name it. 4-methyl heptane. Methyl heptane. This one, don't let the little cross here freak you out. That is a carbon. So 1, 2, 3, 4 carbons is my longest chain. I've got a methyl and a methyl on the same carbon, so what would this be called? 2, 2, hyphen, dimethyl what? 1, 2, 3, 4. Butane. Math is hard. So, between numbers there's commas, between numbers and words there's hyphens. Ooh, bottom left. 1, 2, 3, 4, 5, 6. Really? Hexane. Good. I'm sure you didn't think any of these would be easy, but they are. All right. This one looks exactly like the one above it. Let's skip it. The first one. What? Yep. Do we see that? 1 carbon. Bless you. Now with this one, we obviously have a triple bond, so what's this called? Ethyne. In this case, we do not need a number indicating location. Why? There's no, yeah, from either side it's 1. So if it's in a situation like that, this also happens in the world of the propes, like propine. Same thing. You don't need a number because if you put it here, it's after carbon 1. If you put it here, it's after carbon 1. Okay? So you only need numbers when there's potentially different places you can put things. All right. This one I want to talk about because we want to try to kill 2 birds with 1 stone. The double bond has to be after the lowest carbon. It has to be because that's what naming is about in regards to that suffix. If the suffix changes, it's -ene, right? Because of the double bond, that takes precedence. So I could easily say I'd make this carbon 2. If I made this carbon 2, this carbon 3, is methyl on the lowest possible carbon it could be on? No, so what should I do? Make this carbon 2. Now, my double bond is after carbon 2, which is the lowest it's going to be, and I have the methyl group on carbon 2, right? So what would this thing be called? 2-methyl 2-bu what? Butene. This 2 people forget. You can't. You can't forget that because I could have a 2-methyl 1-butene. And I just named this one for you. I kind of talked about it. What's this one? Propene. And I don't need a number because I can't have a 2-propene. All right. Longest chain. How many are y'all getting? Yeah, I'm getting 7. 1, 2, 3, 4, 5, 6, 7. That's the longest chain. Oh, Lord. We got 1, 2, 3. So it's not really even to go either way. Which one is the best way to go? From the left. 1, 2, 3, 4, 5. This gets me 2 methyls on 3 versus if I went that way, I'd only have 1 methyl on 3. Right? So what do I call this? No, put them together. Try. 3, 3, 5. Tri-methyl. If your groups are the identical, you put them together. And so if you had 2 ethyls and 2 methyls, it would be blah, blah, diethyl, blah, blah, dimethyl. 3, 3, 5, trimethyl heptane. 3, 3, 5, trimethyl heptane. This is similar. Y'all can do this one on your own. Try it. Holler it out. 2, 3, 4, trimethylhexane. Correct. Do y'all see it? Okay, this one. Was that the same one we just did? Yeah. Okay, so that's 2-methyl-2-butene. What's this one? Two-methylhexane. This is 3-methyl pentane. All right, this one, 1, 2, 3, 4, 5. Same thing as the one above it. What about this first one? One butene. Is that counting? No. All right, this one's a circle. Don't let it freak you out. How many intersections on this circle? 5. 1, 2, 3, 4, 5. Cyclopentene. And he said hex. Well, that's a pentagon. That's not a hexagon. Cyclohexane looks like this. All right. I think we've done this one 3 times already. Might want to take that one off. All right. So you guys can practice some more. Oh, let's do this one. One, 2, 3, 4, 5, 6, 7. This is a long chain. And this is a carbon in that intersection. So what's it called? Not 2, 2, 3, trimethylheptene. Oh, shoot, heptane. 2, 2, 3, trimethylheptane. All right, so we're going to look at isomers now. There's 3 different isomers we want you to be familiar with. All of them are basically different. Well, they're not all structural, but at the end of the day, an isomers are compounds with the same formula, but different arrangement, which could lead to some different things. And we cover the ANGEMENT, which we will cover in great detail in organic if you take that class. But the three we want you to know first are structural isomers. Structural isomers are the easiest. If you look, all three of those structures have the formula C5H12. So you can take the atoms and arrange them in any capacity where you don't break any rules. Everything has to have all those carbons have to have 4 bonds. And how you know they're different isomers is they have different names. So here's a big thing that I often see. You're going to have questions like, draw the 3 isomers for blah, 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 whatever. And say it's a really long structure like this, blah, blah, blah. What is that? 1, 2, 3, 4, 5, 6. That's heptane, right? So what I get students doing is they're like, oh, I'm going to draw this. It's still heptane, all right? So when you are doing these and you're told to find a certain number of isomers, write down the name. That's how you ensure that it's different, okay? Because once the molecules get really long, it's easy to do replications without realizing it. But if you name them, you'll catch it, all right? So that's the first kind, called structural. Positional isomers are simple. Positional isomers are just any of the substituent groups we're going to talk about tomorrow, or any substituent groups in general, or anything like a double or triple bond being in a different place. Those two things here are positional isomers. One is 1-butene, the other is 2-butene. These are positional isomers, 2-propanol versus 1-propanol. 2-methylbutane versus 3-methylbutane, positional isomer, okay? Names are still different though, right? Isomers always have different names. Now this one, it looks weird. Geometric isomers are so important in organic chemistry. And I'm going to redraw this, just line structure. I think it's easier to see. So we know that's 2-butene, right? I could draw 2-butene like this, or I could draw it like this. These aren't the same thing. That double bond locks it in that shape. There is no rotation around the double bond. Those pi bonds are locking it. So these two things act very differently in solution. They have both a 2-butene name, but what you look at is the long chain and how it is on either side of the double bond. Do you see how this long chain crosses across the double bond? That's called trans. So it's trans 2-butene. Do you see how the double bond here, they're both on the same side of the double bond? Same side, they're sisters. Cis 2-butene. Okay? And you could do different substituents, like you'll see, we'll do one today where you have halogens on the ends instead of hydrocarbons. Same thing though, if they're on the same side, they're cis. If they're opposite, they're trans. And in organic, we get into a whole new thing called EZ, the system, and Gegen and Zusammen, these German words everyone's going to be freaking out about. We will cover those eventually. But just know that cis and trans exist, and you'll know when you look at it, you're going to have to name it cis or trans based on how its the layout is for you. Okay? I mean, if I just were to do this, CH3, CH3, if I were just to give you a formula like this, that's butene, but you'd have no way of knowing. You know, you can figure out that's 2-butene, but you can't tell me if that's cis or trans because I'm not giving you the direction of the ends, right? So you have to be given a certain structural diagram in order to tell me if it's cis or trans, okay? Okay, so let's finish these problems, and then I'll let you work on your homework. Write the structures for 3 saturated hydrocarbons, isomers, having the formula C5H12. That general formula is making this what? An alkane, right? Okay, because it's 2N plus 2. So we can start with our pentane, 1, 2, 3, 4, 5. That's always our first one. I like to, my first step in these, pull off a carbon, leave a butane behind, and now I have a methyl group that I could place somewhere. Where should I place this? On number 2. Why can't I put it on number 1? Then it's still pentane. So this is 2-methyl butane. If I move it here, would that be good? Why not? It's still 2-methyl butane. So I'm done with that. So now I'm going to pull off another one. So I've got 2 methyl groups, or what do 2 methyl groups when you put them together make? An ethyl. Let's try the ethyl group. Why doesn't that work? I just made that again, right? So that's not going to work. So I'm going to have to put them on, leave them as 2 methyls. So how do I place them then? Both of them on carbon 2. If you did it like this, that's fine. Doesn't matter. Okay? So this is called what? Make sure the name's different. Dimethyl. What's 3? Propane. 2,2-dimethyl propane. So those are my 3 isomers. I'm nice in this class. We give you the number. In organic, I don't tell you how many they are. You have to figure it out. No, it's awesome. It's amazing. All right, so write the 5 down. Try it. I'm going to quietly draw them. You draw them yourself. There's 5 of them this time. Did y'all get them? Okay, we started with hexane. I took off 1, and so I had a pentane. So I'm like, okay, I can put one of the methyl on carbon 2, but I could also put it on 3. So those are those 2, right? And then I took off 2, which was 2 methyl groups or an ethyl. Adding an ethyl will still not work. That's going to bring me back to the pentyl one. So if I've got 2 groups to place, I've got 2 methyls to place on a butane. I can place it on carbons 2 and 3, or both of them on the same carbon. That would be 2, 2. We good? Okay. How many got it right? Some? Okay, good. All right. Draw structures for cis and trans isomers of 1,2-dichloroethene. Don't let it scare you. Ethene is what? 2 carbons with, okay, so look at how you draw ethene. That's ethene. So how would I draw chlorine for cis? Let's do cis first. I'll draw one here. How do I draw the other? Same way. That's cis. I'm going to draw one here. How would I draw the other? Trans. Okay? All right, now we're going to go backwards real quick. Make sure you can draw these using the names. Start with the base name. I'm going to draw first one a propane. That's 3 singly bonded carbons. And then what am I going to do? I know. What does that mean? A methylon 2 and another methylon 2. 3-hexyne. What does that mean? 1, 2, 3, 4, 5, 6. So what do I have to do? Double? Triple hexyne. So I'm going to go to carbon 3, and after it I'm going to put a triple bond. 3,4-diethylhexane. So I'm going to draw my base, hexane 1, 2, 3, 4, 5, 6. And then on carbon 3, I'm going to put an ethyl group. Ooh. And on carbon 4, I'm going to put an ethyl group. I don't care what direction you put stuff. Just keep stuff out of the way of each other. Don't be like putting them on top of each other like that. All right, I know I haven't taught you this, but the beauty about IUPAC, if you know something about a system, you could probably figure it out. So how many carbons are in the structure first? 1, 2, 3, 4, 5. What do you think this means? Diene. What do you think diene means? 2 double bonds. Where are they going to go? Yep. That's the beauty about the system. I didn't say a word about that, but you could still figure it out. 3,3-dimethyl cyclobutene. Cyclobutene, what is that? It's a square. Butene. Double bond. I didn't mention this with the cyclopentane because I got all thrown off my game because of people calling it hexane. It's hexene. When you're in the circle, because it's a circle, you always assume the double bond is on one, so you don't have to say 3,3-dimethyl-1-cyclobutene. But because we have this is where we decided to put our double bond, you have to, if you make this one carbon 1, you cross over, this has to be 2, that has to be 3. Okay? If you made this carbon 1, that would be 3. But either way, you got to be consistent with your numbering. So I'm just going to make this be 3, and it's going to be, yes, it looks like a fish with a tail. Sideways fish. Okay? Yeah, it's not happening. No desire. All right, we're going to do organic. That's because this is new to you. You're going to get to the point where you don't even flinch when you see this stuff. Like, you see things now that are weird, but your brain is trained very quickly. You won't think of a fish. You'll think, oh, that's a cyclic hydrocarbon. It's going to have a pi bond that could be attacked by a nucleophilic substance. Like, that's where your brain's going to go. Okay, so do that worksheet for practice tonight. Very important. Make sure you're on the game. I'll answer questions about it tomorrow before we do the advanced nomenclature.